All right, so for week 2, day 3, we're going to be doing quadratics review. So things having to do with quadratic functions. So the very first function that I have up here, I put two forms. That one is called a function in standard form. Okay. So if you want to label that, you can, but they call this standard form. Okay. So that's like the basic form that you can see quadratics in. Okay, so ax squared plus bx plus c. Now, in the homework, they're going to ask you a lot of different things based on these quadratics. Sometimes they'll ask you if you can label the axis of symmetry. If you're given an equation that looks similar to this, right, so y equals to, let's say, a 2x squared plus 3x minus 5, or something like that, you can find your axis of symmetry by getting negative b and dividing it by 2a. So whatever b is, you take the opposite sign, and then dividing it by 2 times whatever a is. That's going to give you your x value. Okay, that's what we call our axis of symmetry. That becomes a vertical line you can draw straight up and down. It's supposed to be invisible. Okay, but that creates a symmetric line for your parabola. Okay, because these are all parabolas. Quadratics are parabolas. If they ask you for the vertex, what you do is you find your axis of symmetry first, right? X equal negative b over 2a. And then what you do is you plug it into your formula, and that gives you your y value. You can figure out your y value by plugging in your axis of symmetry. Okay? So that's how we find our vertex. If they ask you for the y-intercept, it's always 0, comma, whatever c is. So if c is a 12, then 0, comma 12. If c is a negative 3, then 0, comma negative 3. That would be your y-intercept. And then sometimes they ask you, is it a maximum or a minimum vertex? Meaning when you draw it, is it opening up or down? Because if it opens up, then it's a minimum vertex. If it's opening down, then it's a maximum vertex. So that's all depending on A. If A is positive, then the graph opens up, which means you have a minimum value, a low value. If A is negative, that means it opens down, which means you have a high point. So like on these graphs right here, you can see a low point or a high point. Okay? So if they're asking for max and mins, you got to look at your A term. And if A is positive, it's a minimum vertex. If A is negative, it's a maximum vertex. Okay, so it all depends on A. Now, aside from that, like I said, if you came in late, you'll have to copy this stuff a little later because I'm going to be going through it quickly. I don't want to make the video like 30 minutes. So for number 2 here, this is called vertex form. So I'll kind of write that down for us here. This is vertex form. And the reason why they call it vertex form is because the HK is our vertex. And you can see right there, it's listed in the actual equation, right? X minus h, and there's a plus k at the very end. So your HK is your vertex. Remember, the h value is always the opposite of what you see. So pay attention to that. Your axis of symmetry is going to be whatever your h is. Okay, so whatever the h value is of your vertex. Okay, so and then the definition for the max and min is the same as before. If A is positive, it's going to be minimum. If A is negative, it's going to be maximum. So I'll just kind of list that right here. Okay. So when we look at the homework that you guys are going to get, so we're going to go into that right now. So you have a bunch of notes that you wrote down right now, and we're about to go into this homework assignment. So it says, for each exercise, identify the error in planning the solution or solving the problem, then write the correct solution. Okay? So for us, they want us to identify the error and then fix it. Okay? So question number 1 says, graph the function f of x equal to x minus 2 squared and then minus 2. How is the graph of the translation of f of x equal to x squared? So they want us to graph it, and then they want us to describe how you moved it. Okay? So first of all, when you're looking at this, okay, that minus 2, which way am I supposed to move, left or right? Is it a left motion or a right motion of 2? You guys remember that? The H case? It's to the right. So I got to go right twice. And then the minus 2 means to go down twice. So look at the way they described it. The graph of f of x equal to x squared is translated 2 units to the left. That's wrong. So when we fix that, we're going to say right 2 units. Okay? The down 2 units part is correct. But I should be moving right 2 units. So in other words, my graph, I'm going to kind of use this as a real quick guide. So don't freak out. I'm just going to move it. My graph is supposed to be right 2 units, down 2 units. It should be right there. That's where my graph should be. I have to go right twice and down twice. Now I know it only looks like 1, but remember the numbers that, whoops, sorry about that. Let me move that back. Give me a second. All right, there we go. So the numbers are 2 and 2, right? 2 to the right, 2 down. It's not by ones. It's 2, 4, 6, 8. So move twice to the right, 2 times down. So there's my answer. Now remember, your normal graph is supposed to look like this. It's going to get a little messy. Sorry about that. But your normal graph is supposed to look like this, like the blue one. So you got to move it over and then down. Okay? So that's how you fix the first one. You're going to move it to the right place, to the right twice, 2 times down. That's where it should be. So what was their error? They moved to the left. Okay? So that's why their graph came out wrong. Are we okay with that one? All right, next problem says, identify the vertex, the axis of symmetry, whether it's a max or minimum value, and the range. Now the range we'll talk about in a bit. Okay? The range has to do with your y values, but we'll get to that first. But let's check to see if their errors are obvious here. Okay? So according to the equation they give me, let me write down my vertex here. In order to actually, let's not do vertex. Let's do axis of symmetry first. That way I already know what to plug in for x. So I'm going to do A, O, S, my axis of symmetry. So that's x equal to negative b over 2a. Well, my b value is a negative 6, so it's going to be negative of a negative 6 over 2 times a is 3. Okay, so let me plug in my information, work it out. So this is 6 over 6. So my answer is 1. So my axis of symmetry is supposed to be 1. And what did they write? A quarter. So this is wrong. Okay? So obviously, if that's wrong, then my vertex is going to be wrong, right? Because of the fact that I need to use this number to plug in my value. So let's find out my vertex. Well, it's going to be 1 comma something. Because remember, you plug in your axis of symmetry as your x value. So if I plug in a 1 into my equation, y equal to 3 times 1 squared minus 6 times 1 plus 2, that's 3 minus 6 plus 2, that's negative 1. So obviously my vertex is incorrect. Because they're saying my vertex is supposed to be a quarter, 11/16. That's wrong. Okay, so I have my axis of symmetry right here. My vertex right there. Okay. Now they want to know if this is a maximum or a minimum vertex. Well, they said minimum. Okay. Would that even be close? Well, my A term is 3, right? My A term is 3. So since A is positive, then vertex is what? Is it a max or a min? A minimum. Is a minimum. My vertex is a minimum. Whoops, sorry. Wrong marker. So at least they got the fact that it was minimum correct. Which way does it open? If A is positive? Up, right? So that means that my range is upwards from the lowest point. What's the value of my lowest point? Well, this part right here, that -1, that's my lowest value. -1, because that's the vertex, that's the lowest part. So my range, let me write this down here, is y greater than or equal to -1. If this was a maximum point, then it would be y less than or equal to -1, because it can go downwards, right? It's opening down. But since this one is opening up, then it's going to go upwards. Okay? So again, if you look at a picture, it's looking kind of like this, where this point right here is 1, -1. So notice how all the values go up, right? They go upwards. So they go as low as -1 on the y-axis, but then they go up from there. So that's why our range is that. So at least they got the range kind of right. They said it had to be greater than or equal to, but I mean everything they did was wrong. Okay? So are we okay with this part right here? Just using our definitions, right? Looking at our definitions, plugging everything in. Let me highlight the range portion. So we found our axis of symmetry, we found our vertex, our range, and whether it was a max or a minimum value. Any questions on this one? Like I said, these are a little bit tougher. Okay, they're a little tougher because they're dealing with quadratics, so quadratics aren't always super easy. So let's look at number 3. This might kind of freak you out a bit, but don't worry. You don't have to actually do the whole problem. You just got to figure out what your vertex is for this one. Okay? It says a ball is tossed into the air from a window. Its path is described by that equation, where y represents the height of the ball in feet above the ground, x seconds after it is tossed. What is the vertex form of the equation? What is the maximum height of the ball? Okay? So, they say that the vertex form is -16 x minus a quarter squared plus 12. So what they're telling me is that my vertex is 1/4, comma 12. Okay, 1/4, comma 12. That's what they're telling me. So I got to check that. I got to see if that's right. So let's figure out the axis of symmetry first so we can eventually plug it in and find our vertex. So axis of symmetry. So my AOS. So x is equal to -b over 2a. b is 8, so -8 over 2 times a, which would be -16. All right. That becomes -8 over -32, which is positive 1/4. So far this checks out. 1/4 looks good. Now, let's plug that into our equation to see what my y value is. So to find the vertex, 1/4, comma something. Okay, now to figure out that something, let me plug it into the y equal to equation. So y equals to negative 16 1/4 squared plus 8 times 1/4 plus 12. Remember, I'm plugging in the x value everywhere where there's an x value in the equation. Well, if you use your calculator, you can do a 4th squared, that's 1/16. 1/16 times negative 16 is negative 1. 8 times 1/4 is 2, plus 12. Negative 1 plus 2 is 1, and 1 plus 12 is 13. Is that the right vertex that they gave us? No, they gave me 1/4 12. I got 1/4 13. This is wrong. Okay? So when they ask you, well, we'll get to that next. Let's write the equation, because I got to write it in vertex form. Remember, the vertex form equation is y equal to a times x minus h squared plus k. What's my a term? According to my equation, you guys have it on paper, right? What's my a term? You can look at the original problem. Negative 16, so all right. Y equals negative 16. X minus, my h term is 1/4. My k term is 13. All right, so there's my vertex form. There, I fixed that problem. And then they said, what is the highest the ball went? Well, remember, which way is this graph opening if a is negative? Down. That means my vertex is the highest point, right? So I'm just going to draw like a little picture here. What's this point up there? Well, we found it's 1/4 comma 13. 13 is the y value. So the highest it went is a height of 13 feet. I think they said feet, right? Yeah. So height 13 feet. And that comes from this idea. That's the highest the graph goes, the vertex. Okay? So the height is 13 feet. See, I could just give this homework to you guys and let you do. I just think there's going to be a lot of people aren't going to be 100% sure because we haven't done this in a while and we forget. So I think a lot of people might really forget and they won't know what to do. And some people will go back and say, oh, I remember Mr. V taught this. Let me go back into my notes. Let me find quadratics. I know he taught it. I know there's a video on YouTube that he did, and you guys can go through the video and do it. But, I mean, that's a lot of extra work. So I just figured, let me just walk them through this stuff again. Maybe it'll trigger something, and you're like, oh, I remember this, right? But there we go. Any questions on numbers 1, 2, or 3? Anything you want me to go over before I go to the back of this thing? Because there are 10 problems. 8 problems, 9 problems. They're not all like this, by the way. Okay, just the front side is kind of hard, but they're not all like that. The back side's a little bit easier on some parts. So we're okay. All right, turn the paper over then. So more of finding the errors. For each exercise, identify the error implying the solution or solving the problem, then write the correct solution. They said, what is x squared minus 10x minus 24 in factored form? Then they walk us through it. They say, well, step 1, you're going to find numbers with the product of 24 and a sum of negative 10. They're doing the x method. They're just not showing it. So then they said, okay, what are some of the factors of 24? Well, negative 1 and negative 24, negative 12 and negative 2, negative 3 and negative 8, negative 4, negative 6. And what do those add up to? Well, negative 25, negative 14, negative 11, negative 10, right? Those factors will add up to those numbers. They said, so use the numbers you found, negative 4 and negative 6, to write the expression as a product of two binomials and they claim that this is the right answer. Okay? Is that the right answer? How do I know? How can I check? Because obviously there's an error somewhere. There's a real quick multiplication I can do to check. Can anybody tell me what two numbers I should multiply? What are those equal to? -4 times -6. That's a positive 24. Is that what is here? No. Those factors don't work. You can't use -4 and -6 because if you multiply them, that comes out to positive 24. And I'm supposed to have a negative 24. Their factors are wrong. That's how you can check if you did your work right. When you factor, check the last two numbers. Okay? So, obviously, not working. Guess we got to do it, right? So, let's go ahead and do this. All right. We know that it has to multiply to -24. And it has to add up to -10. What two numbers can I use that multiply to -24, add up to -10? And we already know we can't use 6 and 4. Anything else? Which one has to be negative? The 12, right? So that means that my factor is supposed to be x plus 2, x minus 12. This is what it's supposed to be right here. Not this. This is wrong. It looks right. Right? It multiplies to 24, adds up to 10, but just not the right way. Okay? The signs don't make sense on that factor. All right. Are we okay with that one? Number 5. What are the solutions of that? So let's see what they did. They started off with x squared minus 16x plus 64 equal to 4. Then they got to x minus 8 squared, which they factored. Okay, they factored it. They did the x method to factor x squared minus 16x plus 64 into x minus 8 squared, and it's actually done correctly, so that is right. Then they took what? What did they do next? How did they get x minus 8 squared equal to 4 to become x minus 8 equal to 2? They took a square root. So if you take a square root of x minus 8 squared, it does become x minus 8, and 4 does become 2. And then they added 8, they got x equal to 10. Did they do anything wrong to solve this? There's something I always tell you guys, when you're solving a trinomial, you always have to set it equal to 0. Did they ever do that? No. So this is wrong. If they don't set it equal to 0, you don't just solve it equal to a number. You got to solve it equal to 0. Okay? If you solve it equal to a number, theoretically, you're solving for when it equals to 4. I need to know when it equals 0 because I want to know the solutions, the zeros, right? Where it touches the x-axis. So the math they did is not wrong. The math they did overall was correct. The way they did it was wrong. Okay? So here we go. What we're going to do is we're going to move this 4 over. So x squared minus 16x. If I subtract 4, I get 60 equal to 0. So now the hard part is figuring out what are the factors of 60 that give me a 16. So we'll think about that right now. And just to make sure, did I do the subtraction? Yes, I did. All right, so what do we get for 60? Say again? Oh, good, good, good. -10, -6. So let's try this right here. I got 60, negative 16, 10, and 6, negative, negative. That makes sense. Negative 10 times negative 6 is positive 60. Negative 10 minus 6 is negative 16. So that's good. So this is x minus 10, x minus 6 equals 0. Well, that means I got to solve for two solutions, right? X minus 10 equals 0. X minus 6 equals 0. So x is either equal to 10 or x is 6. I get two answers. They only got one of them. Okay? And I think it's kind of lucky they did get one of them. But this was wrong because I'm going to put right here, did not set equal to 0. That's the reason why this doesn't work. So it's not like the problem was hard to do, but you have to notice, because if you read it just the way I did earlier, it seems like they did everything right. Right? They did do everything right. They factored, they took square roots, they added to solve. Like, all the math seemed to be correct. The problem is they never set it equal to 0 first. And that's going to be the issue. Right? Anytime they tell you to solve for an equation, setting it equal to 0 is usually the main thing you want to do. Okay? After that, you can start solving. All right, so we're in 5. Like I said, the good news of today is that we're working on the homework together. The bad news is we're working on the homework together, so it takes a while. Okay? So I do apologize for the length. I hope you can appreciate, though, the fact that we're going through it, right? You may actually have to do some of these on your own, but I think some of these will be faster coming up. What are the solutions of this problem here? So notice it's already equal to 0, so that's good. And then they factored it. Is that factor correct? Let's see. I mean, it looks good to me, but we'll double check it. So 6, that's negative 60 and positive 11. That's 15 times 4. No, I can't use that, because they would both have to be negative. That would give me a negative 11, so I can't use those two. What else can I use? Well, instead of racking my brain, let me do this, if you guys don't mind. Let me check to see if their factor is right, because if their factor is not right, then I'm going to spend my time doing it. So let's distribute. That's 6x squared plus 15x. And then this will be minus 4x. Minus 4x minus 10. That's 6x squared plus 11x minus 10. That's correct. That's right. So I just worked it out. I looked at their factor. I worked it out. It does equal to that. So we're good. I'm not going to mess with it. Okay? I'm not going to try to work this out slowly. All right? So we know that works. Okay? So then that means you have to do this and you have to do that. Well, if you solve, what should my answer be here? If I solve it, I got to add 2, right? To solve this part, I got to do 3x minus 2 equal to 0. 3x equals 2. So x would be 2/3. They put 3/2. That's not right. It should be 2/3. Let's check the other side. And they forgot, for some reason, the fraction came out all weird. 2x plus 5 equals 0. So 2x is negative 5 if you move it over. Divide by 2, so x should be a negative 5 over 2. That is not correct. Okay, let me actually just use a marker here. kind of hard to see, but negative 2 over 5. So it should be negative 5 over 2. So that's wrong as well. So they did everything right except for the solving. The solving was wrong. Okay? And notice I got a little lazy. Instead of doing the x method, I said, forget it. I'm just going to distribute. Let's see if it's right. Because why am I going to do the x method if they already gave me a factor? Let me just multiply that out really quick. And if it comes out to the original problem, then I know they did it right. If it comes out to something else, then I know the factor is wrong. Okay? So I kind of used what they gave me to figure this out. All right. Part 7 is not an error problem. And it's quick. But before I go into it, is everybody okay with number 6? All right. So which of the following best describes the graph of the quadratic equation with one real root? If it only has one answer, that's because the graph looks something like this. Now it could either open up or down, but it's going to look something like that. It has two answers if the graph actually crosses twice. So like if the graph looks like this, that has two solutions because it crosses the x-axis 2 times. Okay? If it has no solutions, it's because the graph never touches the x-axis. If it never touches the x-axis, no solutions. They said one real root, one solution. That means that the vertex has to touch the x-axis. So which one is the right answer? C. The vertex is the only one that touches. If it has 2 x-intercepts, that means it has 2 roots. If it doesn't cross the x-axis, that means it has no solution. That's B. If the vertex lies on the y-axis, that doesn't necessarily mean anything. I mean, it can be on the y-axis, but it can be below or above. It can have no solutions, 2 solutions. It has too many options. C is the only one that makes sense. The vertex is on the x-axis. So that one wasn't too bad. That's not an error problem. Let's look at 9. And then we'll do 8. Because 9 is a visual one. I know we only got like 1 minute. The graph relates to the height of a ball tossed in the air to the time from the ball was tossed. What does the y-intercept represent? So in other words, what does this mean? So they threw the ball, and that graph shows you like, okay, the ball was here, and it went up this high, and then it went down. What does that initial height of 6 tell you? Is that the maximum height of the ball? No, maximum height is over here. Is that the ball was tossed from 6 feet above the ground to begin with? Yeah, that's where it started. That's where it started. Okay? You guys have to do number 8. Sorry about that. Oh, by the way, just real quick, guys, look carefully. Number 8, they messed up on the powers. Those should be powers of 2. Okay? So